Okay, welcome back. For the second part of the lesson today, we're going to focus on a specific example of the sinusoids. And at first I want to kind of talk in general about the sinusoid formula and all of its characteristics. And then we're going to look at one typical type of problem. And we're really going to rip it apart. We're going to spend a lot of time on this thing. All right, so first, in general, when we talk about sinusoids, yeah, I know it sounds like the new coronavirus or something. You got to go get a shot against the sinusoids or something like that. It really has nothing to do with that. The sinusoids are a group of periodic functions, and they're usually written in the form f of x equals, now I'm going to write down the way your textbook is writing it right now, a times the sine of b times x minus h plus k, which is slightly different than the way that I wrote it before. The way that I wrote it, the way that I like to think about it, is f of x equals a times the sine of b times x minus c plus d. Having those parentheses actually is important. So if I was going to do anything, I think I might emphasize having extra parentheses around all of that. But then kind of looking at this and kind of taking this apart, what do all of these things mean? So we looked at it very briefly before, but let's spend a little bit more time with it. First, the a value. The a value is called the amplitude. And the amplitude is vertical stretching. So it doesn't change the x and y intercepts, but it definitely changes the maximum and the minimum. And when I say stretching, I could stretch it elongating it or stretching it by shrinking it, by making it smaller. The next is the b value. The b value has to deal with the period. Now we saw that plain old sine and cosine have a period of 2 pi. That means the pattern repeats every 2 pi. But if I have some number in here, I change the period. So we have a magic formula to find the period. 2 pi divided by b, and this is going to be my horizontal stretch. How horizontally stretching it left and right like a slinky, making it longer, making it shorter. It's not going to change the maximums or minimums, but it's going to change the x and y intercepts. And how often does this thing repeat? The next is what the textbook calls the h value. I call it the c value, and that's called the phase shift. And the phase shift is a horizontal translation. Horizontal translation. Remember, translation means sliding things back and forth. Stretching is kind of like taffy, pulling it up and down. So horizontal translation is just taking the whole thing, shifting it left and right, like we did with sine and cosine, to show that they really are similar functions. And then finally, the textbook uses a K. Mostly we use a D for something called the center line. And this is a vertical translation. This is what's going to move it up and down. So this is sliding things left and right, sliding things up and down, horizontal stretching, compressing, and expanding things this way, vertical stretching and combining things this way. Now with the sinusoids, there are two classic types, two main types, and we're going to look at both of these and spend a lot of time with both of these. One of them has to deal with the tide problems. So the two different types of problems that we're going to be dealing with are tide and Ferris wheels. There's lots of other types. there are lots of other types of periodic functions. When you turn on your oven, or if you look at the average temperature over the year, anything that's in this repeating pattern, going up and then coming down, going up and then coming down, all of those are sinusoidal functions. But the ones we're going to focus mostly on are tide and Ferris wheels. There's a really good tide problem in your textbook. I'm not going to do that one, but we're going to do a tide problem first. So there's a very good tide problem in the textbook if you want to look at it. It's on page 437. And it's example number 9. And I would make a note to yourself to go to page 437 and look over example number 9. The calculating the ebb and flow of a tide. We're going to do a tide problem, but it's going to be a completely different tide problem. So here's the general. Very difficult, very frustrating. Play around with these numbers and watch what happens. Really a big part of learning is just kind of playing around with it and see, well, what happens if we do this and what happens if we do that. But now let's take a look at an example. So here we go. So this is our first sinusoidal problem. So in this sinusoidal problem, we're going to deal with is going to be a tide problem. And you're at a marina, and you have a boat stored at a marina, and the tide comes in and the tide goes out, and the high tide on any particular, on some certain day, the high tide on Tuesday occurred at 4:12 a.m., 4:12 in the morning, and the water was 35 feet deep at high tide. Now, that's the high tide. That's the deepest the water's going to get. And of course, the tide starts going out until you get to something called low tide, which is going to be the lowest of the tide. And the low tide on Tuesday occurred at 10:24 a.m. And at that time, the water was only 23 feet deep. Now, we have as much information as we need to answer this question. Well, actually, I haven't answered the question yet, have I? I'm going to ask her a question about how deep was the water at noon, and when was the first time the tide was 30 feet deep. Let's say we have to have at least 30 feet of water in order to launch our boat. So when can we launch our boat on that Tuesday? I mean, certainly we could have done it at 4:12 a.m. It was deep enough, but I don't want to wake up that early. So when after that can we do it? Now, as we attack these different problems, there's really going to be two different strategies. Initially, the first tide problem that we do, and then the first Ferris wheel problem that we do a little bit later, we're going to attack them graphically. We're going to graph everything, graph all this information, and then pull everything off the graph to create the model. Now later, after we've done that a few times, we will be able to, just looking at this information, pull it all off and create the model straight away. But right now, it's very confusing, very difficult, very frustrating to try to get all this information off. So I want to create a graph. And my graph is going to look something like this. Let me use a different color here. I'm going to use blue to represent my tide. And this is going to represent the time of the day. And this is Tuesday. So this is 0 o'clock in the morning. And then 24 o'clock with high noon right here. So the first 24 hours, I'm using a 24-hour clock. So from 0 to 12 hours, halfway here and here would be 6 a.m. and 12, and I'm going to write 18, which would be 6 p.m. And we can kind of fill in all the other numbers, and indeed we'll fill in some of those numbers in a moment. Over here is going to be the depth of the water, and it's going to be in feet. Make sure we're using all our units here. Time of day is time. And I want to graph this information. I've got two very important points here. At 4:12 a.m., it was 35 feet deep. 35 is my deepest, so I'm going to put 35 here. So let's see, so 5, 10, 20, 25, 30. So 5, 10, 20, 25, 30. So just going in 15, 20, 5, 10, 15, 20, 25. Oh dear, I'm going to make that 30. And then go up to 35 up there. There we go, 35. Just to give myself a scale how deep the water was. Now these 2 points are very important points. I'm going to graph them. So at 4:12 a.m., where is 4:12 a.m.? Well, somewhere between 0 and 6. 1, 2, 3, 4, 5. Somewhere, I'm going to say that this is going to be 4:12 a.m. And the water was 35 feet deep. It was the deepest it possibly could be. There's my point. That represents 4:12 a.m., 35 feet deep. At 10:24, so let's see, 6, 7, 8, 9, 10. I'm going to say 10 is right around here. 10:24. I'm going to say that's 10:24. My low tide was 23 feet deep, which was right about here. That's my low tide, 23 feet deep. So again, I'd much rather have a really nicer scale here in a moment. Probably need some more room, make a nicer graph in the future. But what's happening between high tide and low tide? Well, the water is going down. And I get a curve that looks something like this. And as we can see, that's part of one of our sinusoids, isn't it? That's part of one of our sinusoidal curves. Starting at the highest point and going down. And then, of course, what happens next is going to be going up and coming down and going up and coming down. Well, in order to graph this and all this information here and put it in my formula, and let's remember what the formula says. So I'm going to write my formula down here. I've got, sine or cosine? That's going to be a big question. Do we want to write this in sine or cosine? Well, notice, I know where the highest point is. Cosine starts at the highest point going down. So I'm going to write this as a cosine formula. If I knew, I could write it as a sine formula using this point right here, my lowest point going down. Oh no, that wouldn't be sine. Sine would be in the middle. Sine would be in the middle going up. Sine starts in the middle going up. Remember, real quick, we need to recognize these things, sine and cosine. When I talk about sine and cosine, we should recognize sine starts at the center line going up. Cosine starts at the maximum going down. Whenever you think of sine and cosine, we should automatically think about these. Sine and cosine. And here, I know where my maximum part is going down. So I'm going to write this in terms of cosine. So the magic formula is going to be the cosine, I need my amplitude, so y equals a times the cosine of b times x minus c plus d. And I need to put all of these numbers in here. And what goes in here? And do I know everything from here? All right, well, let's talk about how do we find each of these numbers. First, the A is the amplitude. The amplitude is how far above and how far below. How far above and how far below what? How far above and below the center line. D is the center line. D is the center line here, right halfway between these two. So if I've got 35 here and 23 here, and I'm focusing in on 35 and 23, what's halfway between them? Add them together, 30, 40, 50, 58. Half of 58 is going to be 29. So 29 feet is my center line. So actually that's my D value. I just found out my D value. That's 29. My amplitude is how far above and below. How far above am I going and how far below am I going? Well, I go as high as 35 and as low as 23. So I'm going 6 above and 6 below. There's my A value. 6 times the cosine of, all right, here's where it's going to get a little hard. My B is my phase shift. I'm sorry, my period. My B is my period. And remember the formula for it. It's 2 pi over whatever the period is. Well, what is the period? Well, I went from a high of 412 to a low of 1024. How long did that take? How long did it take to go from 412 to 1024? What's that, 6 hours and 12 minutes? But is 6 hours and 12 minutes one complete cycle? No. It only went from the high to the low. How long is it going to go to get back to the high? Another 6 hours and 12 minutes. So the entire period from the high tide to low tide was 6 hours and 12 minutes. Back to high tide, another 6 hours and 12 minutes. The whole period would be 12 hours and 24 minutes. So my period is going to be 12 hours and 24 minutes. I want to put 12 hours and 24 minutes in here. How do I put 12 hours and 24 minutes? Oh, be careful, be careful. Let me grab another piece of paper and let's take a closer look at this calculation. 12 hours and 24 minutes is the same thing as 12 plus 24 over 60, which is going to be 12.4. 12.4 hours. 12.4 hours. Do you see why it's 12.4? 12 hours and 24 minutes. So what's going to go down here is going to be 12.4 times x minus, I'm squishing things in here, C, the phase shift. All right, phase shift of what? Of cosine. Cosine has been shifted. How far has it been shifted? Well, this is where cosine started. What did cosine start at? 4:12 a.m. So I want to put 4:12 a.m. in here. Oh, but be careful. I can't put 4:12 a.m. in there, can I? What is 4:12 a.m.? That's really the same thing as 4 plus 12 over 60, which is going to be, what, 4.2, 4.2, so a phase shift of 4.2 hours. Oh gosh, and there it is. Here is our magic formula, ladies and gentlemen. All right, 6 is the amplitude, how far above and below the center line of 29 I'm going. The period is 2 pi over b. The whole period is 12.4 hours. And cosine has a phase shift of 4 hours and 12 minutes, or 4.2 hours. There's the magic formula. All right, so now let's take that and answer some questions. So on our calculator, we're going to go to our y equals. We're going to type this in. 6 times the cosine of, and remember here, somewhere I said about those double parentheses, I definitely think I want to have 2 sets of parentheses here. Let's make sure. So I've got 1 set of parentheses, open, 2 pi divided by 12.4, 2, where's that pi key? Pi divided by 12.4. Yes, I know I could write that as pi over 6.2, but I want to leave that and leave it in your notes as 2 pi over 12.4 so you can see where it comes from later. And then open parentheses times the phase shift of x minus 4.2 hours, close parentheses, plus my center line of 29. There it is. And pi's, you can imagine I need to be in radian mode. Let me check my mode real quick. Okay, I'm in radian mode. Perfect. So now if I just go zoom trig, it's going to give me negative 2 pi to 2 pi and negative 4 to 4. Nothing's right there. There's nothing there. That doesn't make sense. I need to change my window. So I'm going to go to my window. Now, my x's are my times of day. I'm going to go from 0 to 24 hours. So from 0 to 24 hours, scaled in 1 hour increments on my x's. My y is the depth of the water. Well, I'm going to go from 0 feet deep to, let's go more than 35 feet deep. Let's go to 40 feet deep, scaled in 5-foot increments. So I'm going from 0 to 24 hours, scaled in 1 hour increments. And then I'm going to go from 0, y min, why is the y min -4? What did I do there? The y min is 0 to the y max of 40. I don't know what happened there. Scaled in 5 increments. I don't know what happened all with that. That got weird. Let me double check this. My x's are going to go from 0 to 24 hours, scaled in 1 hour increments. My y's, the depth of the water, 0 to 40 feet, scaled in 5-foot increments. All right, so now let's hit graph. And there's the tide. There it is. Here's where the tide started at midnight, and it was coming in, coming in, coming in. Here was my first high tide. I already know the time right there was 4:12 a.m. And then it's going back out, and then it's coming back in, and then it's going back out. So here's a 24-hour period of my tide. Now, once we've got this formula, we can do anything. We can answer any question we want. Once we've got this formula, it's all about coming up with this formula. And coming up with the formula is very difficult, very confusing, very frustrating. This might be one of those lessons you want to play it again, look at it again. Also, there's another really good example, that example 9 on page 437, completely different numbers. And you might want to take a look at that one as well. But now that we've got this, let's ask some questions. All right, so I think we're ready for questions. Let's see the first question. Find the depth of the water at noon. How deep is the water at noon? All right, so I want to G-solve for an x value, or on the TI's second trace, which is calculate a value for x value. So for noon, what am I going to put in? I'm going to put 12 o'clock. And there it is. The depth of the water at noon is 24.866 feet. How about if I wanted to find the depth at 3 p.m.? All right, again, I'm going to trace or G-solve value, but be careful, what do I put in? If I put 3 in here, if I put a 3, what would I really be calculating? I would really be calculating the depth of the water at 3 a.m. If I want 3 p.m., I'm going to have to put in 15 o'clock and find out that the depth of the water is 33.133 feet. Now, suppose I want to launch my boat, but I have to have at least 30 feet of water. So I want to find when the water is 30 feet deep. All right, so now for this one, I'm going to go back to my y equals, and in y2, I'm going to put in 30 feet deep, and I'm going to graph it. There's my tide, and there's 30 feet deep. So I can see that it's 30 feet deep 1, 2, 3, 4 different times that day. 4 different times it's 30 feet deep. Let's calculate those. Casio users, you're definitely going to have an advantage here. G-solve intersect, and then you'll be able to just kind of hit the over arrow and see all the different times. Second trace, intersect. I need to pull my little, drop my pins. I want to find out the first time in the morning. So I'm using my back arrow to go on this side of that first intersection, hit a couple of times, and it looks like the first time it's 30 feet deep is at 1:43 a.m. Now that doesn't mean 1 hour and 45 minutes. 43 is a little less than a half. So this is a little bit before 1:30 in the morning. You know what? That's too early. I don't want to launch my boat that time. Well, let's see, when is it 30 feet again? 30 feet. Let's see, what's that next time? Now Casio users, you can just hit the over arrow and it'll jump right over there for you. TI users, second trace, calculate, intersection point. Now I want to move my little cursor over to this next point right here. Drop a pin, and I'm going to find out the next time is going to be, it looks like 6:96 a.m. So just before 7 a.m. Well, you know, that maybe that's a little too soon. I want to do it a little bit later. So what's that other time over there? And again, Casio users, hit the over arrow. You already know your answer. TI users, second trace to calculate, intersection button. Gonna use my over arrow, going over here, hit enter, and it looks like it's at 13.83. Which is really 1.83 p.m. right? Subtract 12, so a little bit before 2 p.m. You know what? That sounds like a good day. I can go have some lunch, and then we can go launch the boat. The tide's kind of low. I have to be careful. Don't launch it too soon. If I have to have at least 30 feet deep in order to launch my boat, I'm going to have to wait till 1.83. What would that be actually in minutes? Well, I could do this quite easily. I could say that's 1.83 of 60. And on my calculator, I could do 1 plus 0.83 times 60, and it tells me that is 1:50 p.m. So go launch your boat, but not before 1:50 p.m. The water won't be deep enough. So sinusoids, difficult, frustrating, a lot going on. They will get harder before they get easier, and we'll focus on graphing the information and pulling all the information out of the graph. And after a while, you'll be able to just look at it and you won't need to graph it anymore. You'll be able to see what's the maximum, what's the minimum, what's the phase shift. Am I using sine or am I using cosine? And all that other stuff. It will get a lot easier. We'll do a Ferris wheel will be the next big problem that we'll do in a lesson coming up a little bit later. All right, so now we're all set. You can go do the homework. It's a difficult homework. Tomorrow we're going to be working on a project. More about that. Hopefully we'll have a little bit of fun with that. So you've got a little bit of extra time to work on these homeworks and get them done. Spend some time. Make sure you're getting them right. Work with each other. Help each other out. Don't turn in something that's incomplete. Make sure you understand it. I'd rather get it from you a day or two late when it's complete than on time if it's incomplete. Good luck on this tough stuff.